The era of GPU dominance in AI hardware began in the early 2010s. Early AI models needed vast GPU clusters to function effectively. Over time, GPUs evolved to support more demanding AI applications. NVIDIA's A100 and H100 models are now at the forefront of AI hardware. These GPUs boast impressive VRAM capabilities, crucial for handling large datasets. The energy consumption of these GPUs has also been optimized. By 2025, GPU sales saw a significant increase, reflecting their market dominance. NVIDIA holds a substantial market share, with their products leading the sales charts. This dominance is due in part to GPU's ability to handle parallel computations efficiently. However, energy efficiency remains a challenge for many manufacturers. Despite this, GPUs continue to be the backbone of AI hardware development. Their adaptability and performance make them indispensable in today's AI landscape. As technology evolves, GPUs may face new competition from emerging hardware solutions. Nevertheless, their current role in AI is pivotal and unlikely to diminish soon. The journey of GPUs in AI highlights the importance of continuous innovation. As AI models grow larger, they demand significantly more memory bandwidth. Traditional GPUs often struggle with these requirements, leading to inefficiencies. Researchers found up to 30% of compute cycles wasted fetching memory. Large-scale models like GPT-4 require over 40 gigabytes of VRAM. This requirement can significantly impact both training speed and costs. The bottleneck also affects model deployment and scalability. Memory bandwidth constraints are a critical challenge for developers. Developers must often balance between model size and performance. Efforts to alleviate this bottleneck include novel memory architectures. High bandwidth memory can reduce latency and improve throughput. However, these solutions often come with their own set of challenges. Increased costs and complexity are common barriers to adoption. Despite these challenges, the pursuit for efficient memory solutions continues. Innovative designs promise to reshape the landscape of AI hardware. Future chapters will explore how these advancements impact AI's future. Majestic Labs has taken a unique approach by focusing on memory bandwidth over raw compute power. Their strategy leverages advanced DRAM technologies to enhance memory efficiency significantly. In-memory computing is a key component, boosting efficiency by 2 to 3 times. This innovation allows them to overcome traditional GPU memory bottlenecks. Their hardware specifications include impressive RAM capacity and bandwidth. Comparing with traditional GPUs, their solutions offer a distinct advantage. Their RAM capacity reaches up to 128 gigabytes, with unparalleled bandwidth. This configuration drastically reduces latency, an essential factor in AI workloads. Traditional GPU setups often struggle with memory bandwidth limitations. Majestic Labs' approach offers a more balanced performance profile. Their focus on memory efficiency also results in lower power consumption. This efficiency is crucial for scaling AI applications in data centers. In conclusion, Majestic Labs sets a new standard in AI hardware innovation. Majestic Labs' technical architecture is designed to optimize memory access and reduce latency. They use custom memory controllers to achieve efficient data handling. These controllers drastically reduce latency compared to conventional systems. Novel cache management techniques further enhance their performance. Their architecture improves throughput by up to 3 times. This efficiency is achieved without compromising on flexibility. Their system architecture is built on a multi-layered approach. Each layer is specifically designed to enhance system performance. Their innovative approach allows for seamless data flow across layers. This architecture supports real-time applications with minimal delays. Majestic Labs' design is particularly effective in data-intensive tasks. Their systems are capable of handling large-scale AI workloads efficiently. Overall, their architecture represents a significant leap in AI hardware design. Their advancements indicate a promising future for AI hardware efficiency. Majestic Labs' memory-first solutions are redefining performance benchmarks in AI tasks. In natural language processing, Majestic Labs solutions show remarkable speed improvements. They have reduced inference time significantly compared to traditional GPU systems. Image recognition tasks also benefit from these solutions, enhancing speed and efficiency. Power consumption is another area where Majestic Labs excels over GPUs. Their memory-first approach reduces power usage by up to 50%. Comparing power consumption directly, Majestic Labs solutions are more efficient. This efficiency translates into significant operational cost savings. A focus on memory usage optimizes performance further, enhancing task efficiency. Majestic Labs architecture supports concurrent processing, reducing latency in AI applications. This concurrent processing capability boosts real-time decision-making accuracy. Majestic Labs solutions excel in diverse AI workloads, proving their versatility. This versatility makes them an ideal choice for evolving AI demands. Overall, Majestic Labs offers a compelling alternative to traditional GPU systems. Their approach sets a new standard in AI performance benchmarks. Majestic Labs' approach significantly alters cost dynamics for AI hardware. Their initial hardware costs are higher than traditional GPU setups. However, operational savings over time offset these initial expenses. Over 3 years, total cost of ownership evens out. The long-term savings are due to energy efficiency and reduced maintenance. Majestic Labs systems scale more effectively with growing AI workloads. They can handle increased parallelism without proportionate cost rises. Traditional setups struggle with scalability and cost efficiency. Majestic Labs leverages custom silicon for optimized performance. This results in lower power usage and heat generation. Their systems maintain performance even under heavy loads. In summary, the cost efficiency of their systems is a major advantage. This makes them a compelling choice for modern AI applications. The scalability and cost benefits are clear when comparing setups. Therefore, Majestic Labs offers a forward-looking solution for AI hardware. Majestic Labs technology is gaining traction across diverse industries like finance and healthcare. In finance, companies are using it to enhance algorithmic trading efficiency. These financial firms report up to 30% faster transaction processing. Healthcare providers leverage it for real-time patient data analysis. This real-time analysis reduces diagnosis time significantly, benefiting patient outcomes. In autonomous vehicles, the technology enables quicker decision-making processes. Automakers report a 50% reduction in processing delays. Majestic Labs has partnered with leading tech firms to further expand its reach. These collaborations aim to integrate the technology into cloud computing platforms. Cloud providers expect a 3 to 4 times improvement in data processing speeds. Majestic Labs' adaptive technology allows for seamless integration across platforms. Significant cost savings have been reported, especially in energy consumption. Overall, industries are seeing enhanced performance and reduced operational costs. With growing adoption, Majestic Labs is setting new standards in tech innovation. These advancements position them as leaders in the AI hardware landscape. Companies continue to explore new applications and benefits of this technology. As we look ahead, AI hardware is set for significant transformations. Memory-centric designs are gaining traction over traditional processing power. 3D stacking technology is paving the way for enhanced memory capacity. Non-volatile memory promises faster data retrieval times. Researchers are exploring new materials to improve memory efficiency. Experts predict a 5-fold increase in AI hardware efficiency by 2030. The shift to memory-centric designs could redefine data handling. Increased memory will allow larger AI models to run more efficiently. Energy efficiency is another critical advantage of new memory technologies. This shift may also drive down operational costs significantly. AI systems will require less cooling, reducing environmental impact. Memory-centric architecture could also improve real-time processing capabilities. The next 5 years will see rapid advancements in AI hardware. Investors should consider the long-term benefits of memory-centric hardware. These developments could redefine the AI landscape as we know it. Majestic Labs' memory-first architecture offers a compelling alternative to GPUs. For future-proofing AI investments, consider their innovative approach. Thank you for watching, and don't forget to subscribe for more insights.